Hello, and welcome to my new webinar series geared towards the questions that partners are asking and where Microsoft can help. In this episode, we're going to be discussing artificial intelligence, and I'm delighted to be joined by Phil Harvey, a cloud solution architect from one commercial partner. Phil, thanks for taking the time to be with us today. Would you mind giving our listeners a quick introduction?
Thanks, Dan. So I'm Phil, and I started my career with a Bachelor of Arts in Artificial Intelligence from the University of Sussex back in the year 2000 in what's known as the winter of AI. Since then, I've had a varied career spanning architectural rendering, digital agency work, and being the co-founder and CTO of a data engineering startup. Then, as you said, I'm now a cloud solution architect for data and AI in one commercial partner at Microsoft.
Thanks, Phil. Now, AI, artificial intelligence. It's certainly been top of mind for the last few years, and we repeatedly see the largest tech companies pouring resource into developing solutions and releasing new services. And it seems a natural transition. I mean, we live in a time full of technological advancements where more and more of our lives are intertwined with machines and technology. But for many, AI remains a mystery. And I think what would really help is if we can start today's session by discussing why this technology is having such a profound impact on society.
What you'll see is a lot of slides that go up and to the right that show the amount of data that's now available to us. And those slides are interesting. You can also look at the amount of cloud compute that's available. The thing that's important to me is why data is having a fundamental impact on us as a species. Data gives us new ways of knowing and new things to know. And that's really important. And that's why data science and analytics is so important to us in business and also in our lives. Data also makes software smarter through AI. It's how machines know. You can basically think of that as AI eats data. Now, what this means is there's also a lot of large numbers in terms of trillions of dollars and things talked about in the future at some point, how big the market will be. But this is a huge opportunity now. The tools that we'll talk about today are available to everybody right now.
So let me dive a little deeper. What is Microsoft's approach to AI? Now, I know that this has massive buy-in from Satya and the senior leadership team, but how are we helping to democratize AI and empower every person and organization on the planet to achieve more?
So Microsoft's approach is to amplify human ingenuity with AI. And this covers the pillars of reasoning, how to learn and form conclusions from imperfect data, understanding, interpreting a mix of different data sources, and interacting with people in more natural ways. And I think, as you mentioned, Satya said some really meaningful things in this regard. Our goal is to democratize AI, which means this is about making the core currency of any business the ability to convert their data into AI that drives that competitive advantage. Every developer can be an AI developer, and every company can be an AI company. To do that, we really think about dividing up our offerings in three ways. We have the AI platform that we'll dig into in more detail in this session. We have AI infused into our intelligent products, all the way from Bing through Office to Dynamics and the other business applications that we offer. We also have a set of business solutions and teams who can help build out those solutions with you. Now, Microsoft has been working on the core algorithms, some of which we offer out via API, etc. But we've been hitting human parity and winning competitions with our work in artificial intelligence, all the way from the ResNet Vision test through to squad reading comprehension. And this is something you're going to hear more about in the coming months. Across the board, we're starting to do human parity level work with algorithms and artificial intelligence and bringing that capability to our partners and customers. All of that's based on a set of very solid AI principles: fairness, reliability and safety, privacy and security. Privacy and security being a really hot topic at the moment. So this is based on the idea of transparency of process around artificial intelligence, knowing what data you're using and why you're using it, to make sure the right organizations are accountable for the work that's done. And looping right back round to amplifying human ingenuity, we're thinking about here designing for people, which means designing with empathy.
Okay, so I'm going to put you on the spot here now, Phil. We've spoken about why it's important and what Microsoft are doing in this area, but I want to dive a little deeper. I want to really begin to understand what artificial intelligence is all about and learn about the mechanics and principles behind it.
What you need to do is to start off by understanding what we mean by intelligence. That might sound a little bit philosophical, but I think my favorite misattributed Albert Einstein quote would be a good place to start. I don't know who misattributed it to Einstein, but the quote goes, "Everybody is a genius, but if you judge a fish by its ability to climb a tree, it will live its whole life believing that it's stupid." And I wish somebody had told me this when I was at primary school and I got 0 out of 10 for my spelling test. So being a little bit dyslexic, I spent a lot of my life thinking I was stupid. Turns out spelling doesn't matter so much. Who knew? So then once you have a sense of your own definition of intelligence, you start to look at, what the dictionary says. The ability to acquire knowledge and skills is where things kind of start. So we start off with humans at the center, as we've discussed. That's our approach. We've been augmenting ourselves with tools such as software tools and calculators, even down to sticks and hammers and things like that. So we appreciate that we're not as intelligent. Our intelligence doesn't give us all of the abilities we need. We need to augment ourselves. Now, machine learning as a way of developing software fits within that, and we'll go into a little bit more detail on that next. Where things get sticky is when you start to look at things like the Turing test, which is apparent intelligence. Can you fool a person into believing that a machine is human? And, we'd suggest that you should never fool people when you're working, especially, voice bots and things like that. You should always announce that it is technology at the time. And where things get sort of even stranger is when you move into the world of science fiction and super intelligences. There are lots of conversations happening there because everybody has grown up with some form of artificial intelligence, whether you prefer Star Wars or Star Trek, or you've watched The Terminator or things like that. It will affect how you appreciate what artificial intelligence is and what it could be. Does it scare you or does it excite you, as it does for me personally? So that puts the bar, you can see the green dotted line here, very low on where intelligence for software can lie, which means we can be much more pragmatic and we can embrace these new technologies in our work today. So machine learning fits in to the overall software development and data analytics model. You go from the one side of software-derived data, where the software we wrote collected data for us that we're able to use in analytics to help inform human decisions. That's the top row, and you can see human learning there on the right. The reason we did that is because it allowed us to take more intelligent actions. The world of big data added more data into that analytics. We're starting on the bottom row now. And you can see here machine learning as a use of that data. This is where we get through to data-derived software. The algorithms are different and there are new techniques, but what you get at the end of the day is a new algorithm, a new piece of software with inputs, processes, and actions. And when you connect that up to take action for you, you're starting to have an autonomous system using that learning. Now, this helps us have a definition of artificial intelligence. You can see human intelligence being judged there on the intelligence of the action that's taken. And so we judge artificial intelligence based on the intelligence of the action taken. If you let it take action on your behalf, then you have an artificially intelligent system. And we can see that flow going across time here, where people talked about artificial intelligence and how those systems might be. And with the advent of cloud computing and the volumes of data we had available, you start to be able to do practical machine learning, which is extended into deep learning. These are all ways of generating those algorithms we can put into the systematic environment to give us artificially intelligent systems. And they're artificial because somebody built them, they've been engineered, and they're intelligent because we judge them based on the actions that they take for us. So if you want to look at a few examples there, programming creates some if statements. You can look at machine learning from a decision tree perspective. You generate this decision tree, and that's a piece of machine learning. An automated image tagger comes out of deep learning, for example. None of these independently are artificial intelligence, but when you put that into a chatbot that chooses what to say to people, a recommendation engine that chooses what to show people and how to advise them, all the way through to a self-driving car that's making decisions about how to get somewhere, you start to have artificially intelligent systems. Now, so that's what artificial intelligence sort of is at a sort of pragmatic level. And there are some very simple steps to help you start that journey. The first step is to sort out the data estate. We heard earlier that AI eats data. You've got to have good food to make sure the system is healthy. Then you work out where you're going to activate, what you're going to do with this system. How's it going to take action? Are you advising people? Are you letting it do something automatically for you? And then you think about automating that learning within the system to create an artificially intelligent system. I'd very much advise people to think in those 3 steps. Starting in the wrong place can bring you problems later on. And then you start to look at enterprise scenarios, conversational AI, those chatbots. That's a really easy place for many people to start because it creates a new channel to communicate with your customers. You can talk about intelligent apps and adding systems to your existing applications to make them smarter, all the way through to that business process automation.
Thanks, Phil. So can we now start looking at some of the technologies that we're developing?
If we look at this overall chart, you'll see I've grayed a couple of the things out here. What we're going to talk about first is the technologies for enhancing the work you do at the moment, from cognitive services, bot frameworks, search, Power BI, those kind of technologies. And we're going to pick up the ones most relevant to the artificial intelligence conversation. Good place to start is with bots, conversational user interfaces. There's a lot of conversations happening between partners and customers in this space at the moment. Think about a bot as being great at scaling conversations, automating routine transactions, and going where the users are. So coming off the web page, out of your traditional app, into those messaging apps, places where people are having conversations, putting humans first. Bots are very bad at passing the Turing test, becoming Skynet, or any kind of magic. While some people may talk about them in this way, I don't like talking about magic. I like talking about real things that actually work. Some of the bot patterns that we're seeing relate to information retrieval, helping people find stuff, intelligent search, if you will. Transactions, things like asking HR, can I have my P60, that kind of stuff. The advisory role to have a conversation about what people want and help them get through to the right option, all the way through to those social conversations. So there's patterns you can look at and find and be inspired by. Our bot framework is a way of building that bot. It's that interface framework to help you build into those channels. We have Node and C# supported at the moment, and there's a bot connector that helps you go out to common channels. So build the bot once and push it out to multiple channels. So that could be Teams, that could be Slack, it could be Facebook Messenger, Skype, those kinds of things. When you want to add intelligence to your bot, you need things from the toolkit, such as the cognitive services we'll cover later, and LUIS. So LUIS is the language understanding service, and what it does is it takes what somebody types, an utterance, and returns you a structured piece of JSON based on what that matched within the system that you've built, the model that you're working with. Now, an utterance, as I mentioned there, is what somebody types. Within that, you have the entity, which is the thing they're talking about, and the intent, what they'd like to do. And getting data structured in this way is much easier to handle programmatically and get you started much quicker.
Now, I've used this, and I have to say it's super simple to set up. If you want to see it working, head over to my website at azuredan.co.uk or get started on your own by visiting qandamaker.ai. So tell me, Phil, what about cognitive services?
So the cognitive services are powerful pre-built models that we provide. They're provided via REST API, so get yourself a key and start building. Because they're RESTful APIs, you can integrate them into any language that can call across the internet. for example. So whether you're using Macs or PCs or Node, Python, any of these platforms will be able to use cognitive services. There's lots of information available on GitHub, Stack Overflow, those kind of things. So it's really straightforward to get started. The cognitive services themselves cover, as it were, the senses: vision, speech, language, knowledge search, and labs. You'll see things like computer vision. You'll see a video indexer for applying these to video files as well as still images. Speech for speech to text, translation, speaker recognition, things like that. Through to language, where you'll analyze the things that have been written or said when you've taken them from speech to text. Through to the Q&A maker we just saw an example of previously, to the search APIs. Now what you're getting here is the power of the Bing search engine to use within your applications via API. So don't think of what's in the browser, think of the great developer experience of being able to do image searches via an API to build into your app. There's also the labs, and these are experiments from Microsoft Research, which are kind of early releases. So go and have a poke around and see what you think. The cognitive services are powerful and pre-built. So the software as a service, kind of get what you're given. Really useful in a lot of cases. In some cases, you'll want to start to customize the service. So at this level, you have things like custom vision, custom speech. The Lewis service we heard about in the bots case can also be used in other cases. Things like the custom decision service and the Bing custom search service. You'll notice green boxes on here. This means that the services are going GA and have an enterprise-grade production SLA with them as well, which means that you get early access to things and you can track that roadmap through to relying on these services as you would with other Microsoft services. So digging a little deeper and going into vision, how machines can see the world. You've got your computer vision API. Now, what you'll see here is an example on the right, and you can pick up these examples from the documentation pages of the kind of output you get. So you've got here categories, descriptions, tags within the image, all the way through to useful metadata, such as the dominant colors in the image. If we take a look at the Face API, you can record faces for helping with identity scenarios. You can also work out where the face is in the image, all the way down to the pitch, yaw, and roll of the head based on understanding the facial features. It can tell you if the person has a beard, if they're wearing glasses, all those kind of things, all the way through to the emotion of that face. Are they angry? Are they happy? So a lot of rich information from pictures from these powerful pre-built models. The custom vision service, for example, allows you to bring in your own images. You're creating a classifier, for example, or an object detector, and you'll need sort of a minimum of 30 images per category. You train the model in a few clicks through the web interface. You can evaluate it and understand the precision and recall of that model and test with a few images before using it as an API as you would with any other cognitive service.
This is something that I've been playing around with, and I have a working demo available on my site. If you'd like to see it in action, again, head over to azuredan.co.uk and have a play. Now, this next bit we've worked on in the past, and we've actually recorded a video of the process. Now, I don't want to steal your thunder, so I'm going to let you explain, but what I'll do is I'll put a link to the resource at the end of the segment.
The Text Analytics API gives you a useful set of data from blocks of text, very much like the Vision APIs gave you useful blocks of data from images. This will give you the language, key phrases, sentiment, and recognized entities. It's available as a JSON document, as with the other APIs. And for example, here you get 5,000 free transactions a month, which gives you a lot of text to play with to work out what to do. This is something that I'm particularly interested in myself, and I was looking at an example of quite a large block of text and using these capabilities, these powerful pre-built models within Data Lake Analytics, which is a piece of technology we'll talk about later. As Dan mentioned, we've done a video on this, Much Ado About Data, and there'll be a link to that. Connecting that through to business cases can be very important. So you've got to think about where you have these large blocks of text, whether it's news and social media, emails and chat transcripts, educational texts that you might have, all the way through to bots generating new text for your business. All you need here is the ability to divide that text up in time, work out who the characters are, and you can get useful new insight about areas of your business that you might have been blind to before.
So, Phil, could you tell us a little more about the wider data platform?
Okie doke. So we saw this diagram slightly faded out before, and we talked about the technologies on the right, cognitive services, bot framework, and you can see in much ado about data, a use of Power BI. At the bottom of this diagram, you see the journey of data: data, storage, intelligence, and action. This very much maps onto our 3 steps we talked about before: sort out the data estate, work out where to activate, and then do something with artificial intelligence. On the left-hand side, you see the data sources. These could be apps, sensors, and devices, things like that. You have the orchestration technologies to help you move that data around, things like data factory, data catalog to help you record and document the things that you did, and event hubs for capturing data that's pushed at you in near real time. The middle section starts off with data storage. So Data Lake Store is a way of storing multi-schema data in a very secure and scalable manner. You can go all the way through Data Warehouse, SQL Azure, Cosmos DB for NoSQL use cases. This supports the Mongo API, the Gremlin API, and is globally scaled with guaranteed latency on reads and writes. You can even look at SQL Server 2017. You might install that in infrastructure as a service, and that in itself is a full machine learning platform which supports R and Python. To do your analytics piece of work to really understand the data, you can look at Databricks, which is a great tool for data wrangling and processing preparation, including some of the machine learning work that we'll come on to in a second. Data Lake Analytics is in there. This is almost serverless for data processing. You only pay for the query minutes that you use. You don't have to worry about managing the cluster. Stream Analytics will give you that in-stream SQL-like query, and HD Insight is the Hadoop stack, including Spark and Kafka and things like that, to allow you to build out that cluster as best suits you. So we mentioned Databricks. You're able to run your machine learning on there through Python and R and other languages, for example. We have tools such as Machine Learning Studio, which is a visual drag and drop interface for those base machine learning scenarios, a great place for sketching, through to the experimentation service, and Batch AI, which allows you to manage a grid of compute for doing those hardcore deep learning workloads. In the middle, you have the data science and the deep learning virtual machines. These will give your data scientists and machine learning engineers a place to explore and to work with lots of pre-built tools, and you can inject these into your secure VNets to make sure that they're working in the environment that is most suitable for your organization. So you can see here how we go through the stages of preparing and sorting out your data estate to applying some intelligence and then connecting through into action, either through visualizing that in Power BI or delivering that data through to your applications or your bots. Another way of looking at this stack is by skill set, and you can see here how we've got a spectrum from a developer who'd use pre-built services such as the cognitive services and bot framework to add that intelligence into your experiences. The data professional layer, which includes SQL Server and Machine Learning Studio and some of the Databricks pieces in there, all the way up to the code-first machine learning that data scientists want to do. And this is everything from the scale out of that workload through to common platforms and tools such as TensorFlow or CNTK and things like that. So we cover everything from the data journey to the machine learning journey to building out that artificially intelligent system.
Thanks, Phil. So, have you got any demos for us?
Right, if you go to ailab.microsoft.com, you can see some demos of the latest and greatest use of this technology. The one I want to show you today is in the project. So let's go in here, and there's a bot example but we're going to look at artificial intelligence that does drawings for you. This is using what's known as a generative adversarial neural network, or a GAN, and this is using the deep learning technology on the Azure platform to create something novel. So we're going to go through to that site now. You'll find it at drawingbots.azurewebsites.net. Now what this is going to do is to create a picture of a bird based on what I type in. Now there's a default in there, but I'm not going to use that because otherwise you probably wouldn't believe me, Dan, would you? So I'm going to say, let's say red bird with yellow wings. So it's just a piece of text I've typed in. Hitting create on that and we'll see the image appears of a red bird with yellowish wings. So another example here, I could say purple-beaked yellow bird. Anything you type in you can understand will create that picture of a bird. These birds don't exist. This is not looking up from a catalogue. What the neural network is doing is taking the piece of text and based on a huge number of images that it's learned from, it's generating a new picture. Now this is hugely impressive, and it means that we can rethink the way that we approach certain pieces of work. So you could, for example, in advertising, as opposed to hiring models and all that kind of thing, you could generate the pictures using a neural network based on a description of what you want. That could change things significantly. And all of this is possible right now, as we said at the start. You've got things like the cognitive services, which are the pre-built models, and there are things like this you can build. If you sort out your data estate, if you use the deep learning capabilities on Azure, you can build tools like this.
Thanks, Phil. I really appreciate you taking the time to be with us today. Now, we also have a few resources available. As always, we have the Microsoft Partner Network. Then we have the Microsoft AI School. We also have the official AI website, in addition to a great book written by Microsoft called The Future Computed. Finally, we have our own UK cloud solution architect site, the Azure Citadel. As always, it's my wish that you've enjoyed the session, and I'd like to remind you that these are driven by you. Simply reach out to me on social media if there's anything you would like to see, and I will source the experts and make it happen.